Can AI handle repetitive digital tasks that takes us hours to complete? What if AI could handle all of these tasks by simply watching and understanding your screen? No complex coding. No specialized APIs. Just AI that sees what you see. Today, I'm going to show you how Microsoft's OmniParser V2 is eliminating these digital headaches by giving AI true visual understanding of any screen it encounters. You'll learn how this groundbreaking technology works and how you can start using it yourself with zero API costs. OmniParser V2 was released by Microsoft in February 2025, but most people still don't realize how revolutionary it is. Unlike traditional AI tools that need special access to interact with software, OmniParser V2 works just like your eyes do. It sees what's on screen and understands it. In the next few minutes, you'll discover the 4 major problems OmniParser V2 solves, how it achieves 50 times better accuracy than previous technologies, the research breakthroughs that make it possible, and how to set it up yourself with no API costs. If you've ever wished your AI assistant could actually see what you're working on, this is the technology you've been waiting for. Let's start with the 4 major problems OmniParser V2 solves. Problem number 1. Repetitive data tasks. How much time do you spend copying information from one app to another? From emails to spreadsheets, websites to documents, these tasks are perfect for automation but historically required complex coding for each specific application. Problem number 2. Software testing headaches. For software companies, testing interfaces is crucial but incredibly time-consuming. Traditional automated testing requires writing and maintaining specific code for every element of your interface. When your UI changes, your tests break. Problem number 3. Accessibility barriers. For users with disabilities, navigating digital interfaces often depends on whether developers have properly implemented accessibility features. Most developers don't do this, thereby creating significant barriers to digital access. Problem number 4. Agent limitations. Current AI assistants are incredibly knowledgeable but completely blind to what's happening on your screen, limiting their ability to provide contextual help or perform tasks for you. What makes OmniParser V2 different is that it solves all 4 problems with a single breakthrough approach, giving AI actual visual understanding of screens. So how exactly does OmniParser V2 work? The process happens in 3 crucial stages. Stage 1 is visual element detection. First, OmniParser uses what researchers call a YOLO-based segmentation model to identify everything you can interact with on screen. Buttons, text fields, checkboxes, drop-down menus, anything a human would recognize as clickable or interactive. This detection system was trained on over 67,000 different screen images across multiple platforms, giving it an incredibly broad understanding of interface elements. Stage 2 is element classification. Next comes the real magic. OmniParser finds elements and understands their purpose. It can tell that this is a submit button, that's a username field, and this is a menu drop-down. This is where OmniParser V2 makes its biggest leap forward. The original version could only correctly identify 0.8% of elements on the screen spot benchmark. Version 2 achieves 39.6%, that's a 50x improvement in accuracy. Stage 3 is relationship mapping. Finally, OmniParser creates what researchers call a structured points of thought map, understanding how different elements relate to each other. It knows that this text label describes that input field or that this button submits this form. Think about how you navigate an unfamiliar website. You don't need instructions, you intuitively understand how elements relate to each other. OmniParser V2 brings this same intuition to AI. From research perspective, OmniParser V2 is based on groundbreaking research that is bound to have a significant impact on the field of AI vision and interaction. The core innovation is called structured points of thought for unified visual text parsing, which means creating a bridge between what AI sees and what it understands. When tested across 8 different datasets, OmniParser V2 established new state-of-the-art performance. On complex interfaces, it can identify elements with 27.9% to 56.7% accuracy depending on element type, far beyond previous capabilities. What makes this particularly powerful is its versatility. OmniParser V2 works with multiple AI systems, not just limited to Microsoft. Now that we understand how it works, let's explore the practical applications that make OmniParser V2 so valuable. First, workflow automation. OmniParser allows AI to handle complex workflows across multiple applications. It can extract information from emails, enter it into CRM systems, update spreadsheets, and even generate reports, all by visually understanding each interface. Imagine having an AI that can process invoice emails, extract the relevant data, enter it into your accounting software, and even prepare payment approvals without any specialized integrations. Another application is intelligent testing. For software development, OmniParser transforms testing by allowing AI to interact with applications just like human testers would. It can explore interfaces, identify bugs, and verify functionality across different screens and states. In recent implementations, testing time was reduced by up to 60% while increasing coverage by 40% compared to traditional automated testing. Next application is accessibility enhancement. For users with disabilities, OmniParser can create bridges between different interaction methods. Someone can use voice commands, and the AI will understand which elements on screen they're trying to interact with, even if the application isn't natively accessible. Lastly, autonomous agents. Perhaps most exciting is how OmniParser enables truly autonomous AI agents. These agents can learn to use any software by simply observing it, then complete complex tasks across multiple applications. OmniParser works with any application as is, whether it's a modern web app or legacy software from decades ago. The best part? OmniParser V2 is completely open source and free to use. Here's how you can get started. Option 1 is through GitHub repository. The complete code is available on GitHub at Microsoft/OmniParser V2 with comprehensive documentation and examples. This is ideal if you want to understand the internals or customize it for your specific needs. Option 2 is Hugging Face integration. For a more streamlined experience, OmniParser is available on Hugging Face, allowing easier integration with existing ML workflows and models. Option 3 is Zero API Cost Setup. One of the most exciting options is running OmniParser V2 with Qwen 2.5 VL locally. This setup allows you to have full visual AI capabilities with zero ongoing API costs, perfect for consistent, high-volume usage. Option 4 is OmniTool Docker Container. For the simplest setup, Microsoft provides OmniTool, a Docker container that packages everything you need to get running quickly, including integration with your choice of language models. To run OmniParser V2 effectively, you'll need a modern GPU, NVIDIA RTX series recommended, 16 GB plus RAM for optimal performance, and basic familiarity with Python or Docker. I've included links to all these resources in the description below, including a step-by-step setup guide for the zero-cost local option. Let's recap what we've learned about OmniParser V2. It gives AI the ability to visually understand and interact with any screen. It achieves 50x better accuracy than previous screen parsing technologies. It's based on groundbreaking research with a structured points-of-thought approach. It enables automation, testing, accessibility, and autonomous agents. It's open source and can be set up with zero ongoing API costs. We are witnessing the early stages of a major shift in how AI interacts with computers. As OmniParser technology improves further, we'll see increasingly sophisticated AI assistants that can truly see what we see and help with complex digital tasks. What repetitive computer task would you most want to hand off to an AI assistant? Let me know in the comments below.